I'm here to talk to you today about Java in serverless land. I work for Oracle. I work on the fn project, which you saw demoed by my colleague Chad in the keynote this morning. I work in Bristol in the United Kingdom. And I'd like to just start by repeating some of the things that Chad said so that we understand what we mean by serverless and what we mean by functions and functions as a service. So fn project is a serverless platform, but what does that mean, right? So serverless is a word with lots of interpretations. So the way I'm going to use it today, serverless is a way to create applications without having to think about infrastructure. And people often joke, serverless, yeah, of course there are servers. And it's similar maybe to a wireless. If you open your wireless router, there are lots of wires, but you don't have to think about them. And the same serverless, you don't have to think about the servers. Of course, they exist. The unit of things that you deploy to a serverless platform is the function. And Chad showed some functions this morning. And so serverless platform, sometimes called functions as a service or FaaS platform. I say FaaS because it's a nice short word. It's easy for me. So it's worth then explaining what exactly do we mean by a function. So functions are they are short-lived, small, packaged, and individually deployed pieces of code, self-contained, testable. They can be updated individually, so you don't have to update all your functions at once. One at a time is fine. And they are event-driven in the sense that a function exists to respond to something that's happened. So an event usually could be an HTTP request has come in, or it could be on a timer or something that's listening to a queue. The function is event-driven. And so the event comes in, the function is created, it responds to the request, and then it's finished. It's ephemeral in that sense. And because they're ephemeral like that, they have to be stateless. If you want to store state, it has to go somewhere else, into a database or something. The FaaS platform's responsibility with regard to functions then is to create them on demand, and if there's lots of requests that come in at once, to create lots of them. And when the number of requests drops down, the number of functions drops down. So a key critical point of a FaaS or serverless architecture is that when there is no demand, there's no application and there's no cost to the user. So I'm going to talk to you today about, well, firstly about what is the current state of Java as a language for use in this kind of application environment, what the future holds, and how fn project treats Java as a top-class language, and what we do to support Java on serverless. So I'll start with an observation. You saw in the Obermeyer-Sans sort of section at the start of the keynote this morning, Java is the #1 programming language, and this is repeatedly found in industry surveys. But if you look at the serverless.com survey of what languages people use in serverless, you find Java is the #3. And it's not really even close. Python, 35%. JavaScript, 35%. Java, 10%. This is consistent. And other languages make up the rest. So why is it like that? Why is there a difference between regular, traditional non-serverless application language patterns and serverless language application patterns? So I was brainstorming with my colleagues and some friends. We came up with some possible arguments. So is it actually even possible to use Java on serverless? Yes, it is. Like right from the very start, serverless FaaS platforms have supported Java as a language. So possibly, maybe, is it just the case that FaaS is a scripting language, and Java's not typically associated with being a scripting language? So perhaps if FaaS is a sort of scripting language for the internet, then Java's not naturally going to be popular there. But repeatedly in industry surveys, we see that serverless adoption is growing and is projected to continue growing. And this is more than just scripting languages. There's people who are wanting to build whole applications on top of serverless platforms. And the reasons are primarily cost and also sort of developer empowerment and ease of development. So is FaaS more than just a scripting language for the web? Yes, and it's becoming more than that, like all the time it's growing. So can Java development habits be used for FaaS platform? And when I say developer habits, what I mean is like Java developers tend to all use IDEs. They tend to have a good debugger. They use source control, lots of professional software development practices. And maybe FaaS just doesn't let you work like that, so Java customers would feel uncomfortable. It used to be the case that one of the FaaS platforms, you had to type your code into a text area on a web browser. And I think Java programmers would find that a bit uncomfortable. But I'm going to show you, when I do the fn project demo, and Chad showed a little earlier, that Java development habits are easily supported alongside FaaS deployment. So the last question then is maybe there's just something about the JVM which makes it unsuitable for these kind of workloads. So can the JVM effectively run short-lived apps like this? Yes, it definitely can. And I'll show you why later. So I'd like to show you this blog post that was written by an industry analyst, British industry analyst called James Governor. He was on stage at Java 1 last year, making the same claim that when web companies grow up, they turn into Java shops. And it's a slightly funny thing to say because it's like growing up and becoming a bit more kind of mature in your outlook. But his assessment is, I think, quite accurate that when you start developing something, it's easy to pick any language. Whichever one you happen to know the best is probably the best one to start with. But as your companies grow bigger and your products grow bigger and they start to acquire more users and you start to think about needing 24-hour support and then scaling out and scaling up your development teams, then Java becomes a much, much more popular choice for companies as they scale up like that. So when web companies grow up, they turn into Java shops. And he cites as examples Twitter, who now are one of the biggest JVM users, Facebook, who were famously quite anti-Java until they found out about Hadoop and became one of the biggest Hadoop users on the planet. And it's a pattern he's seen again and again in his experience in the industry. So the question is then, what does grown-up Java development look like? Because it seems like if web companies can grow up and turn into Java shops, so serverless platforms are typically only a few years old, and people using them have therefore only been doing so for a few years. As they're growing up and maturing, can they become Java shops on serverless? And so I started to think, what does grown-up Java development look like? And the idea is that if we can sort of decide what features we're looking for in grown-up Java, and if we can show that serverless platforms support those, then there's every reason to think that Java can become as popular as any other language on serverless. So what does grown-up Java development look like? So firstly, Java developers these days, they like using plain Java. Everyone likes writing simple code, simple, clean code. The days of heavy frameworks where you have to extend something or inherit from something in order to get something done are past. Those sort of frameworks aren't popular anymore. People want to be able to structure their code how they like so that they can use it to interoperate with other things, other JVM languages, which may not support whatever Java language feature your framework wants. So people would like to use plain, simple, Pojo everywhere kind of Java. There's a very strong acceptance of open source in the Java community. Java's been open sourced itself over 10 years, and people are used to having tools and platforms and utilities and libraries which are all open source, and you want to control-click in the IDE and find out how something works. For me personally, that's been a big appeal of being a Java developer because the IDE integration and everything being open source means every bit of code that I use, even if I haven't written it, even if I don't want to change it, I can still read it, and I can read how even the people who wrote the Java core libraries themselves write Java, and I feel I can learn a lot from being able to do that. So there's this really strong open source ethos in Java, I think. And like I've just said, there's this huge number of available tools and libraries. So Maven and the Sonatype repository have done a brilliant job for years and years at maintaining this amazing place that you can download reliably libraries from and import into your projects and use very, very easily. So my fourth one then is complex applications. So people use Java to build complex applications. And in this sense, I don't mean that the application is complex because people made it complex. It's because the domain, the problem that you're trying to solve is complex. And so people use Java to solve complex problems, so necessarily the applications are complex. And if you weren't able to do that on serverless, then you wouldn't be able to use serverless for complex applications, right? And then the last point, then, is that people want to be able to use the JVM effectively. The JVM, as we know it today, is 2 decades in development. Yes, over 2 decades in development. It is very flexible. It's highly tunable. There's a huge number of configurations that you can run a JVM in, both pointing downwards to accurately and usefully use the hardware that it's running on, but also pointing upwards. Any company of any size that uses the JVM is probably got many engineers who know how to tune the JVM to specifically support their type of application, be it garbage collection tuning or compiler settings or any of the other kind of hundreds of settings you can actually use with the JVM. So my argument here, and what I hope to persuade you today, is that those 5 things can be possible on a serverless platform, and that FN project specifically has worked to achieve this, and so therefore we can expect Java on serverless to become a popular choice. So I will introduce you then in more detail to the FN project. So FN, as I mentioned at the beginning, it's an open source functions as a service platform. Here's our logo. Here's our website. Please visit it. And you can find us on GitHub as well. We'll be linked. If you visit that, you'll be easily able to get to our GitHub site. So FN is fully open, which is great. I love working on open source. I've worked on open source for years. It's an Apache 2 licensed product. All development happens, and Chad made a big point about this in the keynote this morning. All development happens open source, and when we run FN internally, we are using the same open source FN that you yourselves can download and run, right? There isn't like a private FN that we have in Oracle that you can't really have. It's fully open, Apache 2 licensed. So Oracle doesn't try and make any say about who can use it, where you can use it, and the license about how you can use it is very clear. You can run FN anywhere across a data center in a large replicated cluster. Everyone who does development, they have a laptop just like mine. They do their development on there. And I've seen people running FN project even on Raspberry Pis to do some kind of home automation where the event-driven application is like, the event is, I've come home, and the function is, please open the garage door so I can walk in. Different from other FaaS platforms, functions on FN are containers. So this is a container-native functions platform. This gives us a good deal of flexibility about what we allow inside a function. There isn't just a simple short list of languages you're allowed to use. Almost any Linux application can be containerized, and anything that can be containerized can become a function in FN. I think of containers as being like a sandbox for a process. So some people try and use a container like a VM. It's like a small self-contained computer, but it's more for me like an individual process that runs in the same place, it runs on your host, but it's in a sandbox, so it has some protection against being able to alter other things. If you want a much, much better explanation than that, I recommend a talk by Jesse Frazell called Containers from User Space, which was a keynote at a Linux conference recently. You should just find it on Google. It's a brilliant talk. The last point, of course, fn, like I've said, fn provides strong support for Java. I'd like to now give you a demo of running Java on fn. So, question to you. Can you all read that? Is there anyone at the back? It's too small? You okay? Okay, one thumbs up, thank you. Okay, so like Chad's demo this morning, I'm going to start with an empty directory. I've installed the fn command line client. I'm using Linux, so I won't use brew install to get it, but there's instructions on the website, fnproject.io, if you want to install it on Linux. But different from Chad this morning, I'm going to do my fn init with --runtime equals Java. Okay? And whereas before I started with an empty directory, now, hopefully this is familiar to most of you, right? I've got a POM, so this is a Maven project, right? pom.xml is the project definition for a Maven project. Source, main, Java, com, example, fn, like standard Maven directory structure. And hello function is the name of the class in there. And there's a unit test in there. And immediately, if I wanted to, I'm not going to because it'll take too long, I could start running my Maven commands. The POM that's been generated, I'll show you that just quickly. It's 60 lines. It just defines a library that there's a dependency on a library which can help you write functions, and the testing framework, and there's a dependency on JUnit because we have unit tests in there already. And it's easy, if you know Maven, to add more dependencies. Any library you want to use, any compiler, Maven plugin that you want to use, you can just add it to the POM as you would normally. We'll look at the code. Hopefully, any of you who are Java programmers can understand what's happening here. There's a class and a method on the class, an instance method, handle request. Doesn't have to be called that, but it is in the template. It takes a string as input, and it returns a string as output, and you can see the line that's just checking if nothing's been passed in, so say world, otherwise say hello, the name that was passed in, right? So this is, the trivial kind of example code that you'll see out of the box when you just initialize a new function. There's a unit test which just asserts that behavior which I've just shown you. And the only other thing here is func.yaml, which is the metadata file which defines to fn how to represent this as a function. And then, so the name of the class and method is defined here. The fact that it's a Java project is here. It's got a name, which is just the name of the directory that I created it in. Yeah, and some details about how it's going to be built and how it's going to receive its data. But nothing like tremendously complicated, I think. So fn run, hello world. This is exactly what you'd expect. And what's happened there is Maven package has compiled, so yeah, a Maven package has compiled that, built a jar, and then that's been built into a container image, which has been run in order to provide hello world as the output. And if I say like day, you can imagine what's going to happen here, right? So that concludes the demo. It's a very short one this time. Here we are, right. So hopefully I've shown you, anyway, that the Java that you need to create a function is very simple. There's no framework to use. There's nothing to inherit. You don't need any dependency, actually. We added one because there are some utility functions, but you don't need it. fn itself, Maven, I've shown you the code, so what I just showed you is obviously open source, and it's actually built into the fn tool anyway, so that's open source by definition. Everything I've just shown you is open source. And because it's a Maven project, you don't have to use Maven. The template uses Maven, but you're free to use any build tool you like. So you're free to take advantage of any of the libraries that you know and love from working in Java for so long. Also, because it's just files on disk that were created there, any of the tools like my IDE that I like, my source control, check that in with Git, run it through Jenkins and code coverage analysis, and any other tool that you're used to using with Java is available for you to use here. So hopefully I've convinced you, like 1, 2, and 3, yes, yes. So let's move on then, complex applications. And of course, well, I'll just remind you, when I say complex, I mean we're able to describe complex problems, right? So our answer to this, Chad demoed it this morning, is fn flow. So the question is, right, if you have a complex app, you have a complex domain, and you decompose everything into these nice, small, individually scalable and testable functions, then surely, if you have a large application, you would end up with a large number of functions, and then you have a coordination problem. How do you get this function to run, then this one, then that one, or that one, depending on what this one did, and then everything fanning out, and then at the end wait, and how do you do error handling, and how do you do retries during this kind of thing? So fn flow is our answer to that. This is not a new problem for software, right? Workflow definition has been a problem in software for, I guess, decades. And there have been a lot of solutions like business engineering process language and sort of JSON document describing what you want the workflow to be, this kind of stuff. But in a FaaS kind of serverless world, the whole model of how things are created is very developer-centric. So we really want a different kind of answer to those things. We want something that's flexible and powerful, but also is just written in code. Code is already a very good mechanism for describing something you want a computer to do, so why would you want a different way to describe a workflow than you would to describe an algorithm? Flow, so flow is the thing then, it lets you build these rich, reliable, scalable applications. There's a lot of concurrency options, fanning out, fanning in. Like I said, delays, error handling, all that kind of stuff is supported by Flow. But regular functions define workflows, right? There aren't functions and workflows, there's just functions. Right? And some of them happen to use the Flow API, but they don't have to. And they're written purely as code. And this really is like, I'm not just saying it because I like writing code, it's actually kind of a big important thing because it unlocks testability of your workflows, and it unlocks type safety of them. So if you have a function that returns a type of thing, and then you want to pass that thing to the next function, those two functions should have matching types, otherwise it shouldn't be possible to compose them like that, and Flow has a kind of type safety which enforces that. So here's the demo that Chad showed, well, here's a slide from the demo that Chad showed earlier where he was pulling lots of images from Flickr, doing some plate detection functions, drawing boxes around car license plates, and sending stuff to Twitter and to Slack. So I'm not going to do this demo again. What I'm going to do to you audience of Java programmers is tell you how Flow works under the hood, right? I'm going to explain it by analogy with something which maybe some of you know, which is the completion stage API. Excuse me. So, completion stage was added to Java in JDK 8. Right, so it's been around for a few years. And what you have is basically a single class, completable future. And this class implements future, so it is a future, which means it behaves like any other future. You give it some work to do, and it performs that work asynchronously, and then it behaves like a box, and at some point later you can open the box and get the result of the work you submitted. So you can have it do asynchronous work in the background for you. The other thing that completable future implements is the completion stage. And completion stage enables you to chain and join these futures together to compose them in like ways that create complex workflows in Java. So here is an example. I have a function called make HTTP image request. An HTTP image request might take some time, so we don't want to wait for it to finish. We'll get back a future, a completable future, which will eventually contain an image. So this is how typically completable future instance is created. You call some code and it returns you one. Obviously, you can write code that returns one to other people, but it's like that. Then there's this method here. Can you see my mouse pointer? Then apply. So we have image request, then apply this bit of code, and then that returns a new completable future. So what's happened here, what's going to happen here is that when this future has got its result in it, then we apply this lambda and we get back another future. And because we've gone from fetching a picture to detecting faces in the picture, we've now got a completable future of type face detection result. Now we've fetched a picture, we've found the faces in it. We'd like to know whether the people in the picture are happy or sad or angry or surprised or whatever. So we're going to do some mood detection. But we've got three different ways of doing it. There's a simple method, a complex method, and an experimental method. And those three can be all done in parallel, right? So we can use completion stage to fan out. So we can have faces result, then apply mood detection simple, then apply, sorry, faces result, then apply mood detection complex, and faces result, then apply mood detection experimental. And those three in parallel can be done in parallel. Right. The next thing we might want to do is then just wait for all of those three to finish so that we know when we're done. Because they all happened in parallel, how do we wait for all three of them to finish? Do we like block, or it seems like that would be complicated to do. But there's this method on completable future here, completable future.allOf, which just waits for all of those to finish, then run register detection finished. Okay, so we've got a kind of fanning out and fanning back in model, and all this is happening asynchronously. So by the time the sort of flow of code has reached the bottom of here, probably the HTTP image request is still happening. So how do we catch errors in this kind of programming? Because obviously, like, there's nowhere here to do a try-catch around it because every error is happening asynchronously. So completion stage to the rescue. Again, there's part of the completion stage API exceptionally. So if any of these throws any error, end up down here. And I hope that you, as responsible programmers, write better error handling than I do, because this is terrible, isn't it? But hopefully you get the idea, right? You can build these, you can build these things up. And none of the things like making a request, detecting faces, mood detection, the three ways that that was done, registering that it had finished, none of those depended on any of the other ones. They were all independent little units of code that were then brought together into a complex application by the use of the completion stage API. So what happens when you run this code, this workflow of asynchronous actions is constructed in memory and completed asynchronously using the fork join pool. So the fork join pool, since Java 7, I think, has been the standard scheduling thread pool for just submitting work and having it done on background threads. So now, you're wondering why I'm talking through all this in such depth. I'll bring it back to fn flow, what's going on. This workflow of asynchronous functions is constructed in the flow server and completed asynchronously using the FaaS. So the fn flow API and the completion stage API are rather similar. They're not identical because there's a couple of technical differences. But they function very analogously to each other. So just put those both up at once so you can see the similarity. In that sense, Flow uses the fn FaaS as a kind of distributed thread pool. So you can scale these applications out across, as many computers as you have in your fn cluster or your provider's fn cluster. But there's still, the Vista example Chad showed earlier, there's really only about 20 lines of code that actually define the flow, and then there's just a few other functions for doing the scraping and plate detection and so on. So hopefully if you understand completion stage API, then you can sort of reason about how Flow works and how it enables you to build these more complex applications. So the last part then of the Java on serverless sort of wish list is to be able to use the JVM effectively. And like I said, FN project treats containers as functions, right? So you're in full control of what happens when the function is executed. The Docker file that's used to create the image has an entry point, which is literally Java -jar something, something, something. So any of the command line parameters you want to use are available to you as a user. So the question then is just how well can you actually run the JVM, or how can you run the JVM well for this kind of short-lived containerized workload? What we want is fast startup, smaller images, and we want to respect the container environment that we find ourselves in. So remember I said a container is just a sandbox. Some privileges that you would have running on the host are not available to you, and some things like memory limits are presented to you differently. So it's not just the total amount of memory that you can see that's available to you if you're running in a container, for example. Let's just look then at some techniques for achieving these three things. So fast startup, so technique number one, share memory between JVMs. Right? If you come to load something off disk and it's already been loaded off disk for another process, so maybe the second JVM starting up on a host, then sharing memory is going to enable you to start more quickly, especially the JVM itself will probably be in memory if it's frequently being used. So the important realization that makes this possible is that container images are composed of layers, and your application usually is going to be in the very top layer, and then there'll be a layer where you've added Java, maybe a layer where you've put some operating system components. And the point is that if you share layers, so if you have two applications which have a shared base layer, then the files that make up that base layer on the disk it'll actually be the same files with two other images pointing down at that one. So if you put your JVM in a shared layer, in a shared base layer, then two applications that start up in two containers can share the exact same files on disk, which means that the second one that comes to read it off disk might well find that it's still in the disk cache and can therefore access it much more quickly than if it actually has to be read off disk, right? So shared image layers means shared memory. Images in Docker are read-only, remember? So there's no problem about sharing memory. It works fine. So libc, libjava.so, which is the main bit of the JVM, can be shared between JVMs using this common base image. The other thing, then, that we can do to have fast startup is we can observe that the JVM, when it starts up, it does a certain number of things which are entirely deterministic. They're exactly the same every time. And so what we can do is basically do those in advance and cache the result. So since Java 5, which I believe is a long time ago, Java 5's been out for a long time, it's been possible to use this technique called CDS, which is class data sharing. And what this does is it reads all the core Java classes, Java lang string, Java lang hash map, even Java lang object. All of those at the JVM startup get read into memory as bytecode, the bytecode is parsed, and these in-memory data structures are created representing those. So what CDS does is it takes that in-memory thing and just writes it down like that. Okay, so next time you start up the JVM, you can just read that in, instead of having to read, parse, verify all the bytecodes. A new thing, which George Saab mentioned in the keynote as being one of the proprietary features of Oracle JDK, which has now been open sourced and contributed to OpenJDK, is application CDS. So this is the same process, but applied to your application classes. So this is new in JDK 10, OpenJDK 10. And another thing you can do is take the bytecode that represent your classes and compile them to native code, which is something that the JVM will do eventually if it finds that they are becoming a bottleneck in terms of performance, but you can do it upfront in advance. And all three of these techniques are complementary, as in you can do all of them together, and the effect is basically added up. And I've found in some of my testing that you can take hundreds of milliseconds off of JVM startup time by using CDS, App CDS, and AOT. Although the effect of App CDS depends on how big your application is, right? Because it's about your classes that are being optimized. So your mileage may vary. If you use a lot of classes, then the benefit of App CDS will be better, bigger. So the next thing we want to do is to use small container images. So if you just if you'd never done it before and you went to the internet and searched for like, how do I build a container image with Java, and you just did the first thing that came up, you would probably end up with a very large container image, and it would certainly work, but large container images, and they can be up to a gigabyte, I guess, in size or more, but typically if you did that, you might end up with one that's approaching a gigabyte. The problem is, well, there's several. The first problem is the image, when you want to run it somewhere, the image has to be moved onto that machine. 100 megabytes on a gigabit Ethernet network takes a second, like best case. So if you've got a 800 megabyte base image and you want to copy it across even a fast network, there's several seconds that you'll need to wait. It's unnecessary. The other thing is that even once the image is already on the host, there is a startup cost which is proportional to the size of the image. And this is to do with the way that Docker creates caches for the file system. So there's no circumstance where a larger image is better for you. As long as it still does the thing you want, then make it as small as possible. So what goes in a container image, a Java application container image? In order of like biggest thing to smallest thing, operating system components, the JDK, your application code, and then the JVM itself. So here's some ways that you can make those smaller, right? If you want to use a smaller base image, so don't start with from Oracle Linux, or don't start with from Ubuntu or from Red Hat, start with from Alpine. Alpine Linux base image is a full Linux with different libc from normal, but it's still a full usable Linux, and it's 4 megabytes in size. The Alpine base image is tiny, so it's not like, you can save hundreds of megabytes. The catch is that the libc that it uses is different. It uses a library called muzzle instead of glibc, and so there has to be a separate build of the JVM for it, and that's what's called Project Portola. Project Portola is available for JDK 11 in the early access builds, and if there's enough support for it, it will hopefully become a supported build going forwards. So if you are interested in doing this, by like one of the metrics they measure its success by is how often it's downloaded. So feel free to download it and try it out, and it will be noticed that you're doing that, and we will be very grateful. So now you've chopped hundreds of megabytes off of the OS components. The next biggest thing in a typical application is the JDK. And there's lots of bits to the JDK. You don't use them all, right? I mean, I'd be shocked if anyone here uses Swing or any of the GUI graphical toolkit in components in the server-side right? So it's silly having that in your container image because it's just not used. Up until Java 9, there was no way around it really, but Java 9 introduced the module system, and with it came this tool, JLink. And what JLink does is it examines your code, finds out which modules it uses, which modules they use, etc., and it builds a whole set of all the modules that are needed, and then from that it can work out which ones aren't needed, and it just removes them. So depending on how much of Java you use, how many of the different Java core libraries you use, JLink can remove, well, let's say a full JDK is approaching 500 meg in size. Java.base, which is the only one you absolutely need, is 15 meg in size. So that's already a saving of a lot, 90-something%. And you can bring in, if you want to do networking, you need another module. If you want to do other things, you'll bring in other modules. But you can start from Java.base being very small and cut out a lot of unnecessary stuff using JLink. This is Java 9 onwards. Excuse me. Right, so application code. I'm sorry, this is like, I'm not having a go, but like just write less code, use fewer libraries, use smaller dependencies. Maybe this is not a popular opinion, but I think it's okay to implement a single utility method rather than to bring in a whole commons library of utility methods just because it happens to have one that you like to use. Because overall, if you're going to bring in a dependency to your Maven project, a library, and then you're not going to use 95% of it, then you've just brought a lot of stuff into your container that isn't needed. And if they haven't modularized their library internally, JLink won't be able to help you with that. And the last thing, then, that you've got left is the JVM. And I suppose you may be wondering, like, of course I need a JVM. I can't run Java without that. But I will just give you a direction to look for interest, which is this new lightweight VM that has been released very recently from Oracle Labs. It's been available for a long time, but as experimental, and now they made their release recently. Substrate VM. So Substrate VM is a very small, and it operates differently, type of VM. So you take your Java code and Substrate VM, and it compiles entirely down to a native small binary with no dependencies, much like a Go compiler or a C compiler might be able to. And so if you use Alpine Linux as your base image and you use Substrate VM, you can have the whole image be less than 10 megabytes. It's really astounding what it does. It does come with some restrictions. Certain types of Java programs won't be able to use Substrate. In particular, dynamic class creation and serialization are not supported, or dynamic class creation is not fully supported, serialization is not supported. So by all means, though, please look at Substrate because I think it's like a wonderful piece of technology and really interesting. It's part of the Graal project that you might have read about a lot recently because of their recent release. So we talked about fast startup. We talked about building small images. Certainly both are possible. Substrate also has very different startup characteristics to a normal JVM, and it tends to be, for the kinds of workloads that you can use it for, it tends to be it tends to be extremely fast, like 0 milliseconds fast. So the next part then was respecting the environment, right? Respecting the sandbox that the container effectively is around your application. So perhaps you are familiar with this term ergonomics, the science of making things comfortable for humans, I suppose. But in the JVM terms, ergonomics refers to how the JVM tunes itself based on the view that it gets of the hardware that's available to it. There are several things that ergonomics does, but the two main ones are based on the amount of memory that seems to be available. Things like the Java heap size default is chosen. Garbage collection region sizes are chosen. hotspot compiler code caches sizes are chosen. Ergonomics also tries to ascertain how many CPUs are on the host. And from that, so that's reflected in a method that's available to your code here, this runtime.availableProcessors. And many libraries and many parts of core Java libraries use that method call runtime.availableProcessors to size their thread pools. Right? The fork join pool, which I mentioned earlier, uses that call to work out how many things it can run in parallel. And so if you get that wrong, you can end up creating far too many threads. I sometimes run Java on some of the larger bare metal instances in Oracle Cloud. They have 72 cores. Right? So naturally you think, oh, I can do 72 threads at once with no contention. But if I'm using a container that has pinned my application to that one core, then of course I can't create 72 threads because I'll have 72 threads contending to operate on the same CPU. And that's a recipe for having to wait for a long time. These are not transparent. The limits that Docker can apply like that, memory and CPU, they're not transparent. You have to be actively looking for them because the information is available in a different place. So the good news for you anyway, as Java users, is that all you have to do is basically nothing. All you have to do is use a recent version of Java. So since Java 8, when it was like an experimental option, improving in Java 9, in Java 10, they were removed from being experimental to being on by default. And there's improvements again gone into Java 11. Detecting the resource constraints that Docker has applied to your JVM happens silently without you needing to do anything. If you use Java 10 onwards, if you use Java 8, you just have to supply a flag saying, please do that. You don't need to then make sure that your Docker memory limit is matched by how big you size your heap. That will happen automatically for you. Which is great, right? Because in the fn project, when you write something as a function, you'd like to be able to choose independently of that what configuration you're going to use when you run it. Some functions might be larger than others, and you don't want to have to rebuild it with a different argument for how much memory to use for the JVM each time if it can just detect how much memory is available, which is what these features unlock. So then, this sort of completes my set of things that I would like Java to be able to do in order to be a useful candidate for developing for serverless platforms. And I hope I've convinced you as well that all of these things are possible with Java, and that fn project is working hard to make them possible, and that as companies and applications which are based on serverless grow and become more mature, Java is going to be a much more reasonable choice until it's number one in serverless, I suppose, in the end. Why not? And that is then the end of my talk. So thank you very much for listening. Please check out fn project. It would be great to have more contributors. This, part of my job as speaker and community outreach is to encourage people to communicate, so come and talk to me about it. I won't take questions from you now, but please come talk to me. If you see me, I'll be here for the rest of the day. Anything about Java, about serverless, about fn project, I'm super interested to hear what you have to say about it. So yes, thank you very much.終わりです。